Welcome to In 5 Minutes. Now we'll be studying a new topic of pointers, that is dynamic memory allocation. That is, we'll study some functions, that is built-in functions for memory allocation and memory deallocation. Now firstly, what is memory allocation is? Memory allocation stands for creating variables, arrays, structures, that is reserving some memory for our variables in a program. That is called as memory allocation. In simple words, memory allocation stands for defining variables and computer will reserve some memory for those variables. Now what is memory deallocation is whenever variables are not required, computer itself removes variables, arrays, structures from memory, that is cleans up the memory, that is called as memory deallocation. Now we'll be studying dynamic memory allocation using pointers. Till now whatever programs you have done, in those also we defined arrays, structures and simple variables, but that kind of variable creation is called as static memory allocation. For example, defining some integer ij, defining some float array or int array, it is called as static memory allocation. Now let's see what are the limitations of static memory allocations are with some example. Here we define integer I and j, so 4 bytes of memory, then float array a of size 100, so it is nearly 400 bytes of memory space, and integer b will occupy 100 bytes space. Now totally it is occupying nearly 500 bytes of memory. As the program will start, this many bytes, that is this much space of our memory will be reserved for our variables. Now let's take an example that in the initial part of the program we only process b array, and that time we are not utilizing a array at all. So we are utilizing those 50 integers, that is 100 bytes of memory space, but the 100 float memory space, that is 400 bytes of memory space, is just unutilized till that part of program works, but still it is occupying some space in memory. The next part of the program works with array A, that is it does some processing with array A, but that time it is not at all utilizing array B. In that case we are using those 400 bytes of memory, but the 100 bytes of memory which is not used is still occupying memory. That is a drawback of static memory allocation. Here, anticipating some amount of memory is required. We need to define those many arrays, structures, variables in a program, whether in some part of program we are really using them or not using them. They will occupy some memory space. Let's see the second problem or limitation. We have defined a B array, let's say of size 50, assuming we will require 50 variables to be input or processed. But when the program starts working, we need to process, let's say, more than 50 values, that is 100 or 200 values. In that case, my program cannot proceed further. My program will fail. The other way, it is possible that whenever my program works, I never require more than 30 to 40 variables out of my 50 variables used for B. So I'm not fully using the memory that I have allocated. So some part of the array is always wasted when the program starts working. So you can see there are three drawbacks over here. First is we cannot allocate the memory as and when required. We have to allocate the memory, that is define the variables at the beginning of program. Secondly, the memory allocated is initially anticipated, and that much of memory we have to use. We cannot extend the memory, or we cannot change the size of the memory and utilize it. So if the memory requirement is more than what we have allocated in the arrays or structures, then our program will fail. If the memory requirement is less than what we have really allocated, then we are not using the memory space efficiently, so it is totally inefficient use of memory. And also, whenever any memory block is not required, we cannot remove it, we cannot clean the memory. So these are the drawbacks of static memory allocation. Now these drawbacks or these limitations, what you are trying to understand, is little bit technical for you, little bit difficult for you to understand, or maybe difficult for you to digest, but remember these are very important points in case of computer science. Now let's summarize the limitations or drawbacks of static memory allocation. First is the required variables, arrays, structures, etc. must be defined at the beginning of a program block. We cannot define them anywhere. Secondly, the fixed amount of memory is allocated, anticipating certain amount of memory will be required in a program. The allocated memory can be less than or more than what is really required in the program, leading to inefficient use of memory space. Third is the unwanted memory, that is the variables, arrays which are not required, we cannot remove them from memory. So that is unwanted memory cannot be deallocated according to user's requirement. So these are the limitations of static memory allocation, and that's why C provides us something called as dynamic memory allocations and different functions to perform that dynamic memory allocation. But here we require to know pointers properly So if you have not done pointers from beginning, just go through pointers topic from beginning till arrays, pointers to pointers, everything.